Beyond the Big Bang, the black hole that defies scientists measures 400 million times the mass of the Sun. An international team of astronomers, led by the University of Cambridge, has used NASA's James Webb Space Telescope to detect a massive black hole in the early universe, just 800 million years after the Big Bang. As reported in Nature, the black hole is enormous, 400 million times the mass of our Sun, making it one of the most massive black holes discovered by Webb at this point in the development of the universe. The black hole is so huge that it represents about 40% of the total mass of its host galaxy. By comparison, most black holes in the local universe have about 0.1% of the mass of their host galaxy. However, despite its gigantic size, this black hole is consuming or accreting the gas it needs to grow at a very slow rate, about 100 times below its theoretical maximum limit, rendering it essentially inactive. Such a massive black hole at such an early stage in the universe, but one that is not growing, challenges existing models of how black holes develop. However, the researchers say the most likely scenario is that black holes go through short periods of ultra-fast growth, followed by long periods of quiescence. When black holes are dormant, they're much less luminous, making them more difficult to detect, even with high-sensitivity telescopes like Webb. Black holes cannot be observed directly, but are detected by the telltale glow of a spinning accretion disk which forms near the edges of the black hole. The gas in the accretion disk becomes extremely hot and begins to glow and radiate energy in the ultraviolet range. Although this black hole is inactive, its enormous size allowed us to detect it, details lead author Ignas Georgopoulos of the Kavli Institute of Cosmology in Cambridge. Its quiescent state also allowed us to learn about the mass of the host galaxy. The early universe managed to produce some absolute monsters, even in relatively small galaxies. According to standard models, black holes form from the collapsed remains of dead stars and accrete matter up to a predicted limit, known as the Eddington limit, where the radiation pressure on the matter overcomes the gravitational pull of the black hole. However, the sheer size of this black hole suggests that standard models may not adequately explain how these monsters form and grow. It is possible that black holes were born big, which could explain why Webb detected huge black holes in the early universe, argues co-author Professor Roberto Maiolino of the Kavli Institute and the Cavendish Laboratory in Cambridge. But another possibility is that they go through periods of hyperactivity, followed by long periods of quiescence. In collaboration with colleagues in Italy, the Cambridge researchers performed a series of computer simulations to model how this dormant black hole could have grown to such a massive size at such an early stage in the universe. They found that the most likely scenario is that black holes can exceed the Eddington limit for short periods, during which they grow very rapidly, followed by long periods of quiescence. The researchers say that black holes like this one probably eat for 5 to 10 million years and sleep for about 100 million years. It seems contradictory to explain an inactive black hole with periods of hyperactivity, but these brief bursts allow it to grow rapidly while spending most of its time sleeping, Maiolino points out. Since the periods of latency are much longer than those of ultra-fast growth, it is during these periods that astronomers are most likely to detect black holes. This was the first result I got as part of my PhD, and it took me a while to appreciate how remarkable it was. It wasn't until I started talking to my colleagues on the theoretical side of astronomy that I could see the true importance of this black hole. Because of their low luminosity, dormant black holes are harder for astronomers to detect, but the researchers say this black hole is almost certainly the tip of a much larger iceberg if black holes in the early universe spend most of their time in a quiescent state. It is likely that the vast majority of black holes are in this dormant state. I'm surprised we found this one, but I'm excited to think there are many more we could find, Maiolino concludes.